Okay, we have here another integral on the board. I've got the integral of x e to the x dx. And I recently did something really similar. I did the integral of x times sine x. We did that one by integration by parts, but there was a bit of a twist to it, and this one's going to go about the same way. So for integration by parts, I want to set up my DI table, tabular integration. And typically what we prefer to do is we want to differentiate x and integrate e to the x, because when we differentiate x, we're going to get 1 and then 0. So what I want to do instead is make this harder on ourselves and just switch these. So what I want to do is we'll differentiate e to the x and we'll integrate x. Of course, both these things are easy to differentiate or integrate. So on the left-hand side here, we're going to have alternating signs, and I want to have quite a few values just so that we can see the pattern. So then differentiating e to the x, we get e to the x, and then doing it again, we get e to the x. And of course, this is going to go on this way forever. Then integrating x, we'll get x squared over 2. And then integrating again, we get x cubed over 6. But I'm actually going to write this as 3 factorial. We can write this as 2 factorial. The next one will be x to the 4th over 4 factorial. And it's just going to continue on that way with this pattern. So like I mentioned, the problem here is this doesn't really ever terminate. We're just going on and on forever, collecting more and more terms. So let's take a look at what we have. So we're going to have this infinite solution by taking all these diagonals. And of course I have an e to the x and everything, so I'm going to factor that out and just kind of start writing. So for this first term, we have x squared over 2 factorial. The next one, don't forget the minus sign, so we end up with minus x cubed over 3 factorial. And then plus, so you see the signs are alternating, of course, and we're just going to continue with this pattern. Now from here, we're kind of stuck, right? Because we get this big, huge expression, except for the whole thing is, this whole thing here, it kind of looks similar to the power series for e to the x. Okay, now looking at our power series for e to the x, you'll notice it's really similar with, we get the same kind of thing going on with x squared over 2 factorial, x cubed over 3 factorial. Now, one thing, we have 1 plus x here, we don't have it here. So it starts from this point on here, all to the right. And the other problem we have is here in our solution, we've got these alternating signs. Well, in the power series for e to the x, it's all positive. But this is actually easy to adjust if we just look at what happens for the power series of e to the minus x. We plug in minus x everywhere we see an x. So what's going to happen is we start with our 1. This becomes minus x. This, because it's squared, it's still x squared over 2 factorial. This one, because it's cubed, we get the minus sign. We have now exactly what we have here, except for we have this extra 1 minus x. So the fact that we're missing this is actually going to be really easy to fix. So let's just bring down, for our solution, we have e to the x here. Now this whole thing is going to be e to the minus x minus this chunk that we don't have, which is 1 minus x. But then when I distribute in the minus sign here, what's going to happen here is we're going to have this e to the minus x, then we're going to have minus 1, and then distributing minus times minus x gives me a plus x. But now I can just multiply in this e to the x. So e to the x times e to the minus x, we get e to the 0, or just 1. Then for this next term, we get minus e to the x. And then for the last term, we get plus x e to the x. Well, of course, we need a plus c on here. And then what happens is, because we have a 1 here, we can just take this 1 and we can absorb it into this constant. So for our final solution, we just get x e to the x minus e to the x plus c, and that's it. So there you have it. Same solution you get doing integration by parts the normal way. It just took a little bit longer. So we'll stop it there. Thanks everyone for watching. Have a great day.